Okay, there's a really silly mistake I made here, and I didn't even pick up on it because I didn't check what I'd done. I just went on saying things, and many of the things that I said weren't really so. Most of what I said was okay, but fortunately it's fairly easy to fix my error. So, and there's something to be learned in the process, otherwise I'd just trash this and do it right, as I did in the next class. So you'll see that. But anyhow, first problem, we have essentially this matrix defining a transformation from R4, because right here is a vector in R4, a column vector with 4 elements, okay, and a row of length 4 multiplying this. We know that this maps R4 to R3 because there are 4 entries in each row which have to match up with a column of 4 entries. Otherwise we wouldn't be able to do the multiplication. So we know that if this is a mapping from a real space to a real space, it's from R4 because we have to match up the rows with the columns. And it goes to R3 because there are 3 rows, and each row gives us one of these numbers. Okay, well now the question is, what vector, excuse me, or vectors in R4 map to the vector 1, 2, negative 1 in R3? So what we're trying to do, if we're thinking of a mapping from R4, like here's R4 and we're mapping it into R3, what vectors go to the vector 1, 2, negative 1? So we've got 1, 2, negative 1 over here in R3. What vector or vectors does that vector come from, if any? It might be that we can't map anything in R4 onto this vector. Turns out that we can, though. Okay, well, to answer the question, we simply write down an augmented matrix and reduce it, and it reduces to this, and you can verify that's the correct reduction. And then we just interpret these 3 rows as equations, and we've done that here. So we have x1 minus x4 equals 0, x2 plus x4 equals 0, x3 plus x4 equals 0. And that allows us to get x1 in terms of x4, x2 in terms of x4, and x3 in terms of x4. So we see that x1, x2, x3 are equal to x4, negative x4, negative x4, and of course x4 is equal to itself. And that would be x4 times the vector 1, negative 1, negative 1, 1. If we just factor x4 out, this is what we get. And since x4 could be any number, this would tell us that this set of solutions to this consist of all vectors where we multiply this vector 1, negative 1, negative 1, 1 by any old number. Now just to check, let's make sure that the vector 1, negative 1, negative 1, 1 does map to the vector 1, 2, negative 1. Well, you can plug these numbers in here and multiply it out, and you're not going to get 1, 2, negative 1 because there's something wrong with my solution. I hope you noticed it when we went right by it. I'm going to correct it in a minute. Okay. Now, it's important to understand what you do get if this is the vector 1, negative 1, negative 1, 1, or any multiple of that vector. What you get over here is just a 0 vector. You're going to get 0, 0, 0. You're not going to get 1, 2, negative 1. Okay? So what went wrong? Something is wrong because obviously this is not a solution to this. Well, what went wrong was I had a 1 here and I wrote down a 0 here. Okay, just a simple clerical error. Now I should have been thinking a little more clearly about what I was doing. I'm perfectly capable of doing that most days, but today I was either incapable of it or wrapped up in my explanation and not really thinking about where I was heading. Okay, so we get 1 here, which means that instead of minus x4 here, we really get 1 minus x4. Now, we could still factor x4 out of this, this, and this, but we can't factor x4 out of this term. We could factor x4 out of this, but not out of this. Well, we get around that by just saying, okay, we'll factor x4 out of this thing, but then we also have this vector 0, 1, 0, 0. Okay, in other words, we can split this vector into x4, negative x4, negative x4, x4 plus 0, 1, 0, 0, and then factor the x4 out of this part of the vector. And we get this. And now we've got a solution, because you can easily verify that multiplying this matrix by this vector does give us 1, 2, negative 1. Okay, and it's actually pretty obvious why. Yeah, you've got the column 1, 2, negative 1 right here. And having a 1 in the second position here and zeros everywhere else, we have to get 1, 2, negative 1. Now you really want to think about why that is. You really want to be able to see that within the matrix. Why having a 1 in this position and zeros elsewhere picks out this second column. Okay? So that would be the correct solution to what I did. Okay, we'll go on. Much of the rest of what I say here is actually true.